Okay, so we talk about extrema on an interval. Extrema are one of four things. Okay, so absolute minimum, absolute maximum, local or relative minimum. Sometimes it's called local, sometimes it's called relative, and local or relative maximum. Okay, so what those guys are: minimums are low points in a graph, low points in a graph. Maximum are high points in a graph. So what's the difference? Well, absolute means the absolute lowest part on a graph. Okay, so this part from A to B on the interval from A to B, sorry, from A to E. Okay, absolute minimum would be this point here, because that's the lowest part of the graph. That's the lowest y value on the graph. Okay, the absolute maximum would be a D, because that is the top, that is the highest y value, okay, on the interval. So we call those absolute. Okay, relative or local means high points or low points within like a snapshot. So if I were to focus in really, really high here, really, really tight here, this point isn't the overall maximum, but it's for that area, it's a maximum. We call it a relative. If I zoom out, I see that, hey, it's not the highest point. D is the highest point, right? But B is the highest point in that region. So it's relative maximum. Okay, same thing with relative minimum. Relative minimum, C is a relative minimum. It's not the overall minimum, but it is a minimum, right? It is a minimum. So we call it a relative minimum. Okay, so we call the highest point and lowest point overall absolute maximum min. But we call the high points and low points in between there relative maximums and relative minimums. Okay, so more importantly, in terms of derivatives, so think derivatives, think derivatives. So when I say the word derivative, what should be going through your mind? A couple of words. What are the things that should be going through your mind when I say derivatives? Couple words, couple phrases. When I say derivatives, what should be going through your mind? Mhm. Yeah, tangent, right? Slope of the tangent line. Those three words. Slope of the tangent line. Okay? So when we're looking at slope of the tangent line, let me write that down. When we're looking at slope of the tangent line, right? What do you notice about all of those A, B, C, and D? What do you notice about the slopes of the tangent line at all of those points? A, B, C, and D. Mhm. So yeah, so the tangent line, so let's make dots there. So at D, C, B, A. Yeah, at all of those blue dots, if I was to find the slope of the tangent line, what would it be? Zero, yeah, zero. The slope, the tangent line would look like that. The tangent line would look like that. The tangent line would look like that. The tangent line would be horizontal everywhere, right? So horizontal line, if a tangent is horizontal, tangent line's horizontal, the slope's always going to be zero. So at all of these points, they have a slope of zero, or a tangent, or sorry, a derivative of zero. They have derivatives of zero. dy over dx equals zero at all of those points. That's what we're going to do today. How do you find those points without having a graph? That's what this section is about. How do we find all of these points without having a graph? Because we can't use a graph. We can't make a graph. We can't use a graphing calculator. Okay. Yeah, I'll take it. Okay. So if we can't, thank you, sir. Okay. So if we can't use, we can't have a picture, what do? we find the derivative. We find where the derivative will be equal to 0. Where is a derivative equal to 0? And that'll tell me all about those. Okay, so that's what the next section says. So the next section, critical values. So here we go. A function may have both a maximum and minimum over an interval. Only a maximum, only a minimum, or neither. Okay, so just because it's an interval, it could have both, maximum, minimum. It could only have one. It could have the other. It could have neither. Okay? So just because a function goes on an interval doesn't mean it's going to have one or the other. Okay? So how do we find those points? How do I find those maximums and minimums? Well, we use what's called critical values. Critical values. Critical values of x are where the derivative equals 0. So if there's one thing to highlight or underline, that would be it right there. If you can do that, this chapter won't be very hard. Okay? But knowing that the derivative equals 0 is a critical value, what does that mean? Well, that means the horizontal tangent lines, or where f prime doesn't exist. Where f prime doesn't exist, right? That's a vertical tangent line too. That could be a critical point too. Okay. All right. Or an asymptote. An asymptote is where it doesn't exist. Think so? Okay. Okay, so little sentence frame here. A little fill in the blank. The critical points or numbers. So when we find critical values, they're x values. They're x values. So if we were to find critical values, which we're going to do here in about 3 minutes, those are the x values. But maximum and minimums are the y values. So if they're asking you for the overall, if they're asking you for a maximum or minimum, you don't want the x, you want the y. Okay. In other words, if the point 2, 70 is considered a relative minimum, the minimum of the function would be 70, and it occurs where x equals 2. Okay, that's how we would write it. So if you have a point and you know it's a minimum, 2, 70, 70 is the minimum. Where does it happen? At x equals 2. Okay. Okay, so if I find a point, critical values will give you, you'll have points. You'll be like, okay, there's something here, something here, something here. How do I know if it's a maximum or minimum? How do I know if it's a maximum or minimum there, right? Critical values tell you where, but it doesn't tell you what type it is, a maximum or minimum. For that one, you have to use the first derivative test. Okay? The first derivative test says, if the derivative is positive, then it has to be increasing. If a derivative is positive, the function has to be increasing, has a positive slope. If the derivative is negative, then the function has to be decreasing downhill. Negative means negative tangent line, right? And if the function is 0, that means it's not doing either. It's not increasing or decreasing. We call these guys critical points. These are critical values or critical points. Okay. At critical values, it's not doing either. It's not increasing or decreasing. It's one of those peaks. At the peak, it's not doing anything. The derivative is 0. Peaks or valleys, I should say. Okay. All of these blue dots up here, all of these blue dots are critical values. They're all critical values. A is a critical value. B is a critical value. C, D is a critical value. Okay? All of those, at all of those spots, the derivative is 0. Okay? So there's two things we got to do. We got to find the critical values, and then we have to decide if it's increasing or decreasing. Okay? So we have to find all critical values. And is it a max or a min? Okay. That's what we have to do. Those are the things we have to do first. Okay. All right, so let's look at the first one. Example number 1. For each, find the critical numbers. Sometimes they're called critical numbers. Sometimes they're called critical values. Sometimes they're called critical points. They're all the same thing. Okay, so find the critical numbers of f, and then where it's increasing or decreasing, and find all extrema. Okay, so number 1, find all critical values. So how do we find critical values? Go back and look. How do we find the critical values for f? What were the directions? It's the stuff I told you. If there's one thing you take away from today, that's the thing. It keep going. Derivative what? No. There you go. Right here in the green. The derivative, find where the derivative has to be 0. Find where the derivative has to be 0. So we have to find the derivative and then set it equal to 0. Okay? All right, so that's what we're going to do. So the derivative first. 3x squared minus 12x. And then 15 is just a constant, so that goes away. First step, find the derivative. Second step, set it equal to 0. Okay. Solve for x. How do I solve for x here? Yeah, you could do that. Yeah, you could do that. You could do the x, you could factor. But even easier than that, I think there's an easier way than that. Interesting. Yeah, they have a great, it's 2 terms, right? It's a GC, they have a GCF. I can divide them both by 3x. That's what I'm going to do. Three x. So when I divide them both by 3x, I get x minus 4. Just reverse distributive property. That's all it is. Okay. Now, how do I solve? Again, this part right here, the rest of this, believe it or not, the rest of the process has nothing to do with calculus. I'm done with the calculus. That's the easiest part, right? But it's just the stuff you did in Math 2 and Math 3. That's all that is right there. I'm teaching this to my Math 3 students because it's review from Math 2. So that's the big part. There you go, right? Why do I set them both equal to 0? It's a Math 2 question, but I only have like maybe half of the calculus students actually know why, which is kind of scary. Yeah. Why do I set it equal to 0? Exactly. It was multiplication. It's multiplication, right? And the rules for multiplication say if I multiply 2 things and the answer is 0, one of them has to be 0 or both. Well, I don't know which one. So I set both of them equal to 0. Okay. Divide by 3. Divide by 3. 0. I get 0 as one answer. Add 4. I get positive 4 as another answer. Those are my critical numbers, critical values, critical points, whatever you want to call them. Okay? So at those values, I know there's either going to be maximum or a minimum. I don't know which one. I don't know which one. Could be a maximum, could be a minimum. I don't know which one. Okay? So the next step is, which ones are maximums? Are they both maximums? Are they both minimums? Is one of them maximum? Is one a minimum? I have no clue. That's the next step. So the next step is the first derivative test. So now I'm going to do the first derivative test. Okay? The first derivative test says if your derivative is positive, it's increasing. If your derivative is negative, it's decreasing. If your derivative is 0, it's a critical value. Well, we already found the critical values. Okay? So this is what it's going to look like. So you're going to draw a number line. You're going to draw a number line, and I'm going to put the critical points on there. So I have 0 and 4. So 0 we'll put here, 4 we'll put here. Okay. So what I want to do is I want to find out in between. I know at 0 and 4, the derivative is 0. I know at these points right here exactly. I know at these points, the derivative is 0. I already know that because I solved it, right? But in between, I want to know if the derivative is positive or negative, in between. So in between 0 and 4, I'm going to pick a value. Doesn't matter which one. You can pick a decimal. You can pick a whole number. Any number between 0 and 4 you're going to pick. I'll pick 1. What I'm going to do is I'm going to plug it into the derivative and see what kind of number I get. Okay. So I plug it into the derivative. Oops, I should have plugged it in there too. Three minus 12. 3 minus 12 is negative 9. So that means everywhere in between 0 and 4, I'm going to have a negative derivative. Negative derivative. So I put minus signs in between there. Put minus signs in between there. Negative derivative. You could try another number. You could plug in 2, plug in 3, plug in 3.5. But everywhere it's going to give you a negative number. Okay? Now I'm going to try numbers that are bigger than 4 and less than 0. Okay? So bigger than 4, 5. So 3 times 5 squared minus 12 times 5. Okay. PEMDAS says we do multiplication. So I do 5 squared, which is 25, times 3 is 75, minus 60 is positive 15. Positive. So that means everywhere above 4 is going to be a positive derivative, increasing. Okay, so now let me try less than 0. Negative 1. Okay. Let's see, that's 3 plus 12, which is 15. Positive number. So that means it's going to be a positive derivative everywhere here. Okay. So now I have to determine at 0. Before 0, is the function increasing or decreasing? Before 0, so over here, is the function increasing or decreasing? Because the derivative is positive, right? So it has to be increasing. So increasing. And then once it passes 0, it decreases because the derivative is negative. And then after 4, it increases again. Okay? So the graph's going to look something like this. Right? Turns here, turns there. Right? Sometimes we call those turning points. In Math 3, we call them turning points. In calculus, we call them critical values. Okay? When does it turn? When does the graph turn? Okay? So now let's go answer the question. The answer to the question says, what are the critical values? Boom, we got the critical values. 0 and 4. Where is it increasing? Where is it decreasing? So let me find some space over here. Where is it increasing from? Where is this function increasing at? Where is f increasing? Mhm. So what do we call that before 0? Oh, you could write it like that, but more than likely you're going to see it as a in interval notation. Let me write it like this. So where does it? Let me know the words. Where does it start increasing? What x value does it start increasing at? There you go. Negative infinity. And when does it stop increasing? Okay. But that's not the only place, right? So we say or. And where does it start increasing again? 4. And where does it stop increasing? There you go. More than likely, you're going to see it that way in interval notation. Okay. Now decreasing. Where is it decreasing at? 0 to 4. Okay. 0 to 4. Last question. Find all relative maximum minimum. So now I have to determine whether it's a maximum or minimum. Is 0 a maximum or minimum? Mm-hmm. Yeah, exactly. Exactly. You're right. It was increasing before 0 and decreasing after 0. By definition, that's a maximum, right? So we would say relative max at x equals 0 because how do we know it was increasing? I know it's increasing before 0, but how did I know? What told me it was increasing before 0? No. Because it could increase and then keep increasing. What told me? There was one specific thing that told me why it was increasing there. What values? You guys are right there. Okay, so what values though? What value? There you go. The derivative changed from positive to negative at 0. That's what we put. Because f prime changed from positive, f prime changed from positive to negative. When it does that, it has to make a maximum because f prime changed from positive to negative. Okay? If f prime changes from positive to negative, it means it changes from increasing to decreasing. Okay? Because if I just put it went from increasing to decreasing, well, why? There was a reason why it. Get down to the actual problem. Why did it increase? Because the derivative was positive. Okay? How about at 4? What about at 4? It's going to be a minimum, relative minimum at x equals 4 because f prime changed from negative to positive. Relative minimum at x equals 4 because f prime changed from negative to positive. It switched signs. If the derivative switches signs, that creates either a maximum or minimum. They're going to say justify your reasoning, justify your conclusion, justify your answer. This is justification right here. The work is not justification. Justification's actually explaining. Okay? One sentence for each, that's all. Just what creates a maximum or minimum? Well, the derivative changes from positive to negative or negative to positive. That creates it, right? Everywhere here, everywhere we have a blue dot. The derivative was either negative before or positive before, and then it switched after, right? The derivative is positive here, and then after the blue dot, it turned negative. It was negative here, and then after the blue dot, it turned positive. Same thing here, positive, negative, right? Direction changed, I should say. Direction changed. Okay? All right, so now what I want you to do is do number two. Try number two on your own. Try number two on your own. This one, you only have to find the x coordinates of the relative minimum. So they only want the x coordinates of any relative minimum. Okay, I'll give you a few minutes and then we'll do it together. Okay, so find the derivative. Boom. Factor, like you guys did in math 2 and math 3. Okay, so when I factor, I get -3 times x minus 5 times x plus 3 equals 0. Okay, set them equal to 0. Okay, -3 can't equal 0. That's not going to happen. So that one doesn't give me an answer. Okay, but the other two I can solve. Add 5 to both sides, subtract 3 from both sides. Okay, I get two critical values. X equals 5, x equals -3. Those are my critical values, critical numbers, critical points, whatever you want to call them. Okay. So now what the question asked was determine which of those guys is a relative max or minimum. Minimum. Okay. They use the word minima because just in case there's more than one, minima is just the plural of minimum. So instead, that's why they use the word minima instead of minimum, because minimum means there's only one. Minima means there could be more than one. Okay, so we go to first derivative test to determine whether one of them is a minimum, two of them are minima, or none of them. Okay, so we got -3, +5, 0 is probably right about there. Okay. Now we have to figure out what's going on in between and outside. So in between, -3 and 5, the easiest one to use is 0. Okay. One of the biggest mistakes I see is people trying to plug it back into f. Don't plug it back into f. Plug it into f prime. It's the first derivative test. First derivative test means we got to use the first derivative. So -3 times 0 squared plus 6 times 0 plus 45. Those cancel out. Those cancel out. I'm left with +45. I don't care what number it is. I just want to know if it's a positive or negative number. That's all I care about. And it's positive. So that means all the derivatives between these two values are going to be positive, increasing. The function f is increasing in between -3 and 5. Okay. After 5, 6, 7, 8, 10 million, whatever you want to do. Okay. I would plug in nice, easy numbers, 6, 10, whatever you want to plug in. It's literally, you have infinite number of choices. Okay. Since I can't use a calculator, I might just use 10. It's a round number. But you don't have to use 10. You can use 6, 7, 8. You can use a decimal if you want. But these are non-calculator questions, so I would suggest using something that's easier for you. Okay. 100 squared, or 10 squared is 100, times negative 3 is negative 300, plus 60, plus 45. I don't care what that equals. I just want to know if it's a positive or negative answer. That's all I want to know. And I can see that if I add those up, it's going to give me a negative number. It's going to be a negative number. Okay. Since I can't use a calculator, it just helps to do that. Before, negative 5, negative 10, you can use negative 10. Since I use positive 10, it's going to be very similar. Okay. Let's see. So negative 100, so we still be giving me negative 300. Oops, negative there. So that would be negative 60 plus 45. Again, it's going to be a positive. It's going to be a negative number. Don't really care what the number is. It's irrelevant what the number is. What is relevant is if it's positive, the sign. Okay, so it's negative, negative. Okay. So which one of those critical values is the minimum? Both? One? None? Which one are going to be the minimum? Negative 3. Because the derivative changes from negative to positive after negative 3. It does the opposite at 5. That's a maximum. So we would say relative minimum at x equals negative 3 because f prime changes from negative to positive. Relative minimum at x equals negative 3 because f prime changes from negative to positive. Okay. All right. Okay, next one. All right. Okay, so start the next one. Try the next one. Same thing, same question as example number 1, just a different function. Okay, same thing as example number 1, just a different function. So find the, do step 1, critical values. Find all the critical values. I'll meet you guys up there when you find step 1. Okay, so I found the derivative, used quotient rule, just like you guys just did last chapter. Okay, so when I simplify everything, I get x squared minus 4 on the numerator and x squared plus 4 squared in the denominator. I stopped right there for a reason. My next step is set it equal to 0. But I haven't had a rational expression. I haven't had a fraction yet. So what do I set equal to 0? The whole thing, part of it, here's where you find out. If I go all the way back up to the top where I highlighted, critical value. 1 second, let me. All right, so critical values, the green part, again, we're coming back to the green part because, like I said, if there's one thing you could take away from this chapter, it's really the new stuff, where f prime equals 0. Okay? Think of a fraction. Think of a fraction. When does a fraction equal 0? Any fraction. Think of any fraction. Come up with any fraction that equals 0 in your head. What has to be true about it? There you go. Exactly, right? The top has to be 0. The top has to be 0. So for this guy here, for this guy, the numerator has to be 0. So we got to set that equal to 0. How do I get something that doesn't exist? What has to be true there? Yeah, Arthur? There you go, right? So I have to check both. So I have to check where the numerator equals 0 and the denominator equals 0. I haven't had to do that before because I haven't had a numerator and a denominator, right? This guy here, there was no numerator. There was just, you're right, it was just 3x squared minus 12. The last one, same thing, right? I haven't had that situation. So now I do. So I'm going to set both of them equal to 0. Okay? Oops. So I have x squared minus 4 equals 0. And x squared plus 4 squared equals 0. Okay? I got to set the numerator equal to 0 and the denominator equal to 0. That'll give me my critical values. Okay, so the purple part, the purple one, the numerator, there's a couple ways. You can add 4 to both sides and take the square root, or you can just say, hey, it's difference of squares. This is difference of squares, x plus 2, x minus 2. And set those both equal to 0. Okay. Or you could have just added 4. I could have added 4 to both sides and then taken the square root of 4, which is positive 2 and negative 2. So that's how I would have got both. Okay. Now let's look at the other guy. Let's look at this guy here. How do I solve that? No, you don't even need to do that. I need to solve it for x. Solve it for x means take it apart. So I got to take this part, this side apart, so only this guy is left. That's derivative. I don't want to take the derivative. I already took the derivative. Mm-hmm. Square root both sides, right? How do I take away this part? Square root. Right? So square root x squared plus 4 equals the square root of 0, which is 0. Okay. Now what do I do? Mm-hmm. Yeah, it's not difference of squares, so I can't do what I just did before, but it is, I can subtract 4 from both sides. What's going to happen when I do this? How do I solve for x? Mm-hmm. When I square root both sides, what happens? Yeah, it's going to be imaginary, right? Negative root. We don't deal with imaginaries in this class. I only deal with the real numbers in this class. So in other words, this guy is not going to give me an answer. It's not going to give me an answer. How could I have known that from the beginning? I was waiting for someone to say, hey, there's no way you can get an answer, Mr. Flores. Look at the original guy. Mm-hmm. Mm-hmm. Is there any number I could plug in here that would give me 0 as an answer? If I plug in 0, it's going to give me 4 squared, that's 16. If I plug in negative 2, it's going to give me 4 squared, which is 4, plus 4, which is 16. There's no number, right? I need this to be a negative for me to equal 0. There's no way, because I square it here. Any number you square, what happens to it? It turns positive. And then you square it again, it's going to turn positive, get bigger, even bigger. So there's no number that's going to equal that. Okay? Because of that, there's no answer. This one doesn't give me an answer. All right? Okay, so I have two critical values. Okay, those are my critical numbers. How do I tell if they're increasing or decreasing? Hmm? Yep. First derivative test, called the first derivative test. Okay. So plug in numbers in between to the first derivative because it's called the first derivative test. I get -4 over a positive answer, positive 16. That equals a negative number. So that means in between, it's going to be negative number. So let me plug in 3. 3 squared minus 4. On bottom, I'm always going to get a positive number. On bottom, so I'm not even going to worry about the bottom. It's just going to be a positive number. So it's going to be 9 minus 5, 9 minus 4, which is 5, over a positive number. That's a positive answer. Plug in a number less. Square root, or sorry, derivative -3. -3 squared minus 4. I'm always going to get a positive number on the bottom. Always going to get a positive number on the bottom. I'm not even going to worry about it. Still going to get a 5 over a positive, which is just positive. Okay. So increasing before -2, decreasing after -2, increasing after +2. Okay. So I have to write that down. Increasing -infinity to -2, or +2 to +infinity. Decreasing in between. What's the last thing I have to do? Yeah, what are -2 and +2? I have to write which one is which one is a relative maximum, which one is a relative minimum, and then explain why. That's the last thing. Okay, so once you do that, we'll stop there for today. Make sure you write that part. I'm telling you right now, on the next test we take, they're going to say justify your answer. And if you don't justify, work doesn't count as justification. It used to, but not anymore. You got to actually explain yourself. Why is -2 a maximum? Why is negative or +2 a minimum? You have to be able to explain yourself. Okay. All right. And then tomorrow we're going to tackle absolute. So absolute maximum, absolute minimum. That's what we'll do tomorrow. Okay. Which is a